Sudden cardiac death remains a major health-related problem worldwide. In many countries, the burden of sudden cardiac death is extremely heavy, with an incidence as high as 1,000 recorded cases per day. In most cases, sudden cardiac death is caused by acute coronary occlusion. It is estimated that around 10% of acute coronary syndromes manifest clinically with ventricular arrhythmias, many of which are lethal, especially during the first hour after acute coronary occlusion. The pathophysiology of ischemia-induced ventricular arrhythmias is complex and has been at the center of multifaceted research efforts during the past decades. Sympathetic activation occurs early during myocardial ischemia, aiming at restoring contractility of the affected myocardial areas. However, this occurs at the cost of increased anastomogenesis. Indeed, of the various underlying mechanisms, sympathetic activation has been long recognized as a major contributor of anastomogenesis. Despite the accumulated knowledge, the factors modulating sympathetic responses during myocardial ischemia remain under investigation. Endothelin is a 21-amino acid peptide produced mainly by ischemic cardiomyocytes, which also increases myocardial contractility. However, endothelin is associated with a number of untoward effects. In addition to its vasoconstrictive effects, endothelin has also direct arrhythmogenic actions. Moreover, endothelin, acting via its receptors, potentiates sympathetic activation. This action is evident at the myocardial level, but also at the adrenal level, and possibly also at the brain level. Our group has been actively investigating the complex interactions of endothelin and sympathetic activation, a role of endothelin A and endothelin B receptors, and their ramifications on ventricular arrhythmias. For this purpose, we use the ramp model of coronary artery ligation. We have attempted to unravel the underlying mechanisms, focusing on changes in the monophasic action potentials, and on repolarization dispersion.